instruction videos and some extreme testing. Gentlemen and ladies, they are coming. But at the moment I'm still sorting out lamps, because I've got boxes of lamps under the bed, on top of the wardrobe, in the cupboards, on shelves. I've forgotten what lamps I've got. So today I'm going to do a little video all about neon lamps, from the very smallest right up to the more interesting one that I found, which was a 400 watt hot cathode. So if you want to see the interesting bit, it's somewhere at the end of the video. If not, enjoy the video. Speak soon. I've got this tiny little neon running on some DC. As you can see, when I change the polarity, the opposite electrode illuminates. So that's me reversing polarity. You could use it as a little indicator. In this case it appears that the negative is the one doing the illuminating. Well, there's a bit of a close-up, one side to the other. This is this tiny neon on AC, and when we slow the footage down we can see that it's actually oscillating between one electrode and the other with the mains frequency, and the current obviously is going forward reverse 100 times a second, and we can see it on that neon. Now I wonder how long that will last with the incorrect resistor on it. It's quite bright. Let's reverse that polarity, shall we? Something smoking. I think that resistor's getting hot. Well, it's amazing how much light you can get out of one of these little things. Smells like overheated old-fashioned television. I haven't smelt that for a couple of decades. Don't you remember that? I used to pop the back off them old tellies and get the whiff of hot resistor. Cool, that smells nice. That must be an old resistor on there. Wow, that's a well nice smell. But yeah, that little neon there, surprisingly bright. But not for long. That's impressively bright. And it's only got a 4K resistor there, look. I don't know why that's proving so difficult to bust. You know what's going to happen in a minute. That light is coming from that tiny little neon. That is quite unbelievable. Oh, it's failing. Something's getting hot. Yeah, look, that neon's almost had it. Right, I've got to short that resistor out. I ain't having it. I'm going to get a piece of wire. I'm going straight across that resistor. You ready? My patience has run out. Right, here's a little bit of wire on the resistor one end and on the other. That's the end of it. Oh. I think something in there melted, look. Yeah, short circuit. Use it as a fuse now. You know I can't help myself. Just had to. I don't know why. In there we've got a few standard BC and ES ones, and then we've got the tiny little indicator ones in there. I've kept a few of each. These were quite common on panel lights in boiler rooms and things like that. Another little indicator lamp there, look. This one's quite sweet, MES fitting. That's very sweet, that one. This one's a bit unusual in the fact that there's only one connection there, and that's at the bottom, so assuming the top would be here. Strange, isn't it? Neon there. No, you don't get shock off these. Well, I found this one in there. I think that's some sort of induction lamp, or RF. It's a nice colour, isn't it? Maybe we should put that one in the microwave. Quite like that. Might be zinc or something like that, mightn't it? That sort of wavelength. Zinc or cadmium. Don't know. That's pretty cool though, isn't it? I forgot I had that. These lamps are getting a bit old now. You can still find them though. The old Beehive Neons. They come in a few different variations. They're quite nice. As is the case with most gas discharge lamps, current control is in the base in the form of a resistor. If it doesn't have one in the base, it needs an external one, otherwise it becomes one big short circuit. Sometimes they fail in the base, and I cut the base open, make a repair, and then I join it back together, because these things now are quite hard to get hold of. Normally about 5 watts, 230 volts, they're quite nice. Beehive Neon. This one's a slightly different design. Let's turn it on. This one is, I think it's a Queen's Jubilee one, ER, Elizabeth Royal. Again, probably quite old. And the resistor will be in that cap on that one as well. These things come in all sorts of shapes and sizes. I'm using this Martindale lamp tester. Some of you asked what was it. So you just press this little button and stick it on there, and you can verify it's got gas in it at least. So it works. This one's a bit unusual in that it's a pearl one. Again, it's quite old, but it works. There's one of my favourite for the boys down at the lodge. Obviously if I powered it up properly, all of those plates would light up, and there's a tiny gap between the two plates. Yeah, the old Freemasons. This is one of my favourites, the good old spectral lamps. The one on the far right there is the Neon. This is the Philips spectral lamp Neon with the beehive emitters. Let's power this up. There's that lovely Neon. What a nice colour that is. Being driven by that leak transformer just to keep it to 0.9 amps. There's quite a lot of red coming out of that. This neon tube is for obstruction warning lights for aircraft, and I think it comes from a runway. Standard neon, cold cathode, maybe slightly higher current cathodes than usual, perhaps 50 to 100 milliamps, so it's quite a high output. Let's turn it on. As I increase it, there it is. That's nice, isn't it? Yeah, let's wind it back. You can put these on dimmer switches to get that effect. So it sort of joins in the middle. It's bizarre that, isn't it? That's a nice colour. That lights the room up. This is a standard power supply for neon lamps for signs. It just so happens that it runs that spiral neon, no trouble, probably a bit underpowered. Even low pressure sodium SOX lamps have neon in it, and if you're smart you can have some fun with those too. Now then, in this box, finally, we have the absolute holy grail of neon lamps. This is a GEC 400 watt hot cathode neon. Its permanently heated cathodes are quite unusual in the fact that it needs all sorts of transformers and control gear. But, obviously, we've got the equipment. Let's have a little look at it, shall we? That is what you call a proper neon. You can just make out the writing on that. That's old. This is one end of the lamp, and you'll note that there's a nice big bulge in the lamp. That's to accommodate the heat from the permanently heated cathode. In the middle of that tungsten coil is a thorium oxide pellet, which helps with the thermionic emission that's required to get the gas excited all the way along the length of that tube to the other end. So when that's heated, we get like an invisible cloud of thorium atoms. How tasty is that? Don't eat that pellet. I think we should turn it on. Quick test with this. Oh, we can see it's got neon in it. How about that? This circuit will definitely get the lamp to run, but it isn't the permanent solution, because this is very much like the fluorescent circuit, and the starter, you can see that switch down the bottom there. When that's closed, that almost causes a short circuit on the ballasts, because then they're just running those heaters, so the circuit voltage will drop right down to about 8 volts or 4 volts. With two of those in series will be 8 volts, and it's not ideal. It's certainly a preheat circuit. Then of course when we open that switch, voltage rises rapidly right up to 2500 volts, maybe 300 volt peak. With that igniter we'll definitely get ignition. But as I say, it's not a permanently heated circuit. So once you open that switch, the cathodes are no longer heated, whereas really they should be, and there'll be less erosion on it then. So let's have a look at the circuit as it should be, and we'll try that. This is one way of doing it where it's a bit more correct in the fact that the cathodes are permanently heated. I would think the original ballast had a few taps on it for the heated cathodes, but doing it with two small filament transformers, it does the same thing and it works very effectively. The centre tap of the two small filament transformers are our input, live and neutral, for the supply. Obviously once it's gone through that ballast or choke, same thing. This is one of the transformers for the cathodes. 4 volts on the outside. We've got a centre tap for the feed, for the high voltage. Well, I say high voltage, 230 or so. So let's turn the cathodes on, the heaters. Needs a lot of gear to run it. Then all we've got to do is stuff maybe 250 volt through it, limited current, and that will be a lot of red what will come from there. So I'm just holding the camera, reaching for the socket, and I'm going to give it a bit of ignition. It's going to be bright. Right, are you ready? Whoa, that's a lot of red. I don't think the camera can handle that too well. So cathodes are continually heated, as well as main current going down the end. Yeah, it's a lot of red. The camera don't really pick that up that well though. So if I take the main power off, you'll still see heaters on. I'm now going to start this lamp in the same way, or very similar, to a fluorescent tube. So instead of transformers for these heaters, we're going to actually use the ballast. So I'm turning on ballast now, because this switch is closed. The ballast is almost a short circuit, so the voltage from that mains ballast has dropped from 230 almost down to about 8 volts, because there's two of these 4-volt heaters in series. So as with the fluorescent tube circuit, that's where the low voltage comes from for the actual cathodes, because when the starter is closed, the ballast is almost on a short circuit, and there's just enough voltage there just to light these up. Of course, when I open the circuit for the starter, which would be this, voltage from this ballast will shoot up right up to 240 or more, and then we'll run that lamp. So I'm going to open this. You ready? So we're no longer heating those cathodes, but we've got emission. But we probably won't want to do that for too long, because bombardment there will chew away at those cathodes if they're not continuously heated. But that will take quite some time. So just as a quick demo, that works. So it's like a 400 watt fluorescent tube, but it's neon. It's quite bright. That's a lot of red, but sadly the camera doesn't really pick that up too well. There they are, unheated. So we don't want to do that for too long, but it works. There it is, back in the box, once again, probably for another 50 years, before somebody else gets it out and powers it up like we did. At least we enjoyed it, I hope. We're not doing it, eh? Right, I will see you next week. I think I'll finish my Big Mac in my shake. I wonder what we can do with this thing. This looks fun. That's it, I've done my workout. I think that thing's hard work. I think we need to pop it. See you next week.